The first difference is definition and the last difference is the example whenever you are attempting any kind of difference in the paper. That is the general trend you can follow. So what is the definition now? Plastic which softens on heating and hardens on cooling is called thermoplastic. Plastic which do not soften on heating is called thermosetting plastic. Okay, so this is very important. Thermoplastic is formed by addition polymerization and thermosetting plastic is formed by condensation polymerization. Also, thermoplastic, it can be remolded, but thermosetting plastic cannot be remolded. Thermoplastic is having low molecular weight, thermosetting plastic is having high molecular weight. It is soluble in organic solvent, but thermosetting plastic is not soluble in organic solvent. Okay, example of thermoplastic is polyethylene and thermosetting plastic is bakelite. So these one has to remember whenever you are planning for these things. Let us try to understand the next question, that is question 2b, that is explain boundary lubrication with the 5 marks weightage. So what you will do? You will first of all try to explain the application of the boundary lubrication, where this boundary lubrication is used. This type of lubrication is done when direct metal to metal contact is possible due to certain reasons. Okay, so whenever metal contact is possible and you cannot avoid it, at that time you are using the boundary lubrication. This happens when shaft starts moving from rest, speed is very low, or you can say that speed is very low, load is very high and viscosity of the oil is very low. Okay, so for this reason you can use the boundary lubrication. So shaft starts moving from rest, speed is low, load is high and viscosity of oil is low. At that time you can do the boundary lubrication. Okay, now the next thing is, what we are doing in the boundary lubrication is that space between moving parts, that is the part of the metal to metal contact, the space between these two parts, moving parts, is lubricated with the oil layer. It means you are applying your oil layer between these two moving parts. These oil layers cannot be removed easily and direct metal contact is avoided. Okay, graphite and molybdenum disulfide is used for boundary lubrication. You can see the diagram here. There is two metal parts which are in direct contact. In between them you are applying the lubricant film. Okay, this lubricant film is applied. So this is actually the diagrammatic representation of whatever is shown in the theory here. Okay, so what happens? Space between moving part is oil lubricated with the oil layer. You can see here film is applied. These oil layers cannot be removed easily and direct metal contact is avoided. Okay, so example, graphite and molybdenum disulfide is used for boundary lubrication. Okay, the next question, let us try to understand. Look at the diagram. Question 2c, the question asks it, describe permutate process with the reaction. So permutate process they are asking with the reaction. Before we go to the reaction, let us try to describe the reaction entire process with the diagram. What is there? Permutate is shown here, hard water is passed, all the chemical reactions occur and finally we get the soft water. To regenerate the permutate, we can use the NaCl solution. Let us try to understand what is happening inside the container. You are allowing hard water, okay, to pass through sodium permutate. Look here, this is sodium permutate. You are allowing hard water to pass through it. Second, thus what happens when hard water is actually containing calcium and magnesium ions? So what happens when you are passing hard water through sodium permutate? Then calcium and magnesium ions react with it, forming insoluble calcium and magnesium permutate. Okay, so that is formed. The next step, these calcium and magnesium salts are retained on filter bed and finally we get soft water. You can see here in the diagram, hard water containing calcium and magnesium are passed what happens? Hard water containing calcium magnesium, after passing, calcium magnesium will stay on the sodium permuted bed, so sodium and magnesium will get interchange, and when they will get interchange, then we will get the final soft water after the process. See here, after 8 to 12 hours, there are chances that your sodium permuted may get exhausted and stops working. So for that reason, we use 10% brine solution, that is NaCl solution, to regenerate the sodium permuted so that it can effectively work. Okay, so that is one has to remember. Let us see the chemical reaction, what is happening inside the process. The chemical reactions involved for removal of temporary hardness of water in permuted process. See, temporary hardness is because of your bicarbonate salts, okay, and bicarbonate salts are what? Calcium bicarbonate and magnesium bicarbonate. You can see here calcium bicarbonate, okay, so that is actually going to be, this hard water is going to pass from sodium permutate, that is Na2P. Na2P stands for the sodium permutate. What chemical reaction occurs? You can see very clearly sodium is getting replaced by calcium in chemical reaction. So what happens? It comes out to be CaP, that is calcium permutate. Calcium ion is getting retained on permutate, and finally we are going to have sodium bicarbonate as a byproduct. At the same time, you can see here magnesium bicarbonate is passed through the sodium permutate, that is your hard water. Then what happens? Magnesium ions are retained on the bed and we are going to get sodium bicarbonate. Okay, so that one has to remember. So calcium magnesium interchange is there, or you can say calcium sodium interchange is there, magnesium sodium interchange is there, and both these salts responsible for hardness, these ions are retained on the bed of the permutate. Let us see the permanent hardness removal chemical reactions. What are the reactions? It's very simple and very easy to remember. See, we have for permanent hardness, there are the salts responsible are calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. These four salts are responsible for the hardness, okay, or you can say permanent hardness in the water. So how to remove it? You are passing your hard water from the sodium permutate bed. So what happens in the chemical reaction? Your calcium and sodium will get interchanged. Look at the first reaction, CaCl2 plus Na2P. So what happens? CaP, that is calcium, is going to get retained on permutate plus 2 times NaCl, okay, MgCl2 plus Na2P, okay, that is going to give Mgp plus 2 times NaCl. Same way CaSO4, that is calcium sulfate, okay, plus Na2P, that is sodium permutate. So what will happen? CaP plus Na2SO4, okay. At the same time, MgSO4 plus Na2P gives Mgp plus Na2SO4. So these are the chemical reaction, the most simplest one, nothing doing, just replace the ions. You have a sodium permutate, Na2P everywhere, sodium permutate bed, pass a hard water on that. You are aware that for permanent hardness, these four salts are responsible. At the same time, for temporary hardness, bicarbonates of calcium magnesium are responsible, and according to that the chemical reaction will happen. Let us try to move ahead. The next question. What is the question? Question 3a states that explain the classification of polymer according to their structure. So it is very important question that is asked in the paper of the 5 marks. So let us try to learn how to answer this question. Okay, so they have asked the classification of polymer based on the structure. It means that you are supposed to write the definition and draw the polymer based on that. B part is having the weightage of the 5 marks with buffer solution, its types and uses. C part is what is half cell, explain construction and working of standard hydrogen electrode. So these are actually the 3 things that one has to cover. So today we will be starting with the first answer from this is classification of polymer basis of the structure. In that, first classification is linear polymer, second is branched, C is cross-linked polymer. Let us draw the diagram of all these polymers. we are drawing linear polymer. So that is, you have suppose monomers like this. The chain of the monomer is actually having the linear combination of the monomers that results in linear polymer formation. Suppose if you are drawing the branched polymer, then branches of the monomer will be there. That is branched polymer that you can draw here. That is something like this. This is the chain of monomer. And here another branch of monomer is there. So this is actually your branched polymer. Okay. The third type that is actually here is cross-linked type. So what is there in the third type? That is cross-linked polymer. You can see here very clearly, that is, first you have to draw like this one branch, then you have suppose cross linking of another chain, and this is something like this. Okay, so this is something like cross-linked polymer. So what happens, there are three types of polymers: linear, branched and cross-linked as discussed. Apart from that, you can also write down the two more classification on the structure, that is homopolymer. You can see here homopolymer and copolymer. So what is the meaning of this? Homopolymer means it will consist of all the monomers of same type, and copolymer means it will consist of monomers of different type. So you can see here homopolymer is something like this. Okay, it has same monomers, all the A monomers for example we have taken, and here copolymer is something like this. So it will have a different monomers in the chain. So this is your copolymer. Okay, so this one has to remember. So this is also the one more classification on the basis of the structure, and in that again you can go forward and you can see here you can draw the linear homopolymer, linear copolymer. Also you can draw the graft polymer in which the branches and the backbone both are totally different. So that is something like a graft copolymer. Okay, so that you have to remember. The next thing that you have to write is definition of each of them. So what are the definitions? Let us see. Linear polymer. Let us see what is the definition. A polymer molecule in which monomer molecules react with each other to form a long continuous chain structure. You can see here very clearly in the diagram. Here the monomer molecules, as per the definition, the diagram is very clear. The monomer molecules forms a long continuous chain. Okay, so this is your linear polymer. Then you can go ahead and see what is branched polymer. Branched polymer is polymer molecule in which monomer molecules react with each other to form long chain with some branches. So you can see the diagram here. There is a long chain but there is some branches. Okay, so this is your branched polymer. Remember this thing. The third thing, that is cross-linked polymer. Polymer molecule in which monomer molecules react with each other to form a continuous long chains with interlinked with each other. What does that mean? You can see here in the diagram there are chains that are interlinking with each other. So these two chains are interlinked by this chain. Okay, so this is a cross-linked polymer that one has to remember just for the reference. Okay, next question that you can see here. What is buffer solution? State its types and write any three uses. So question B is here of 5 marks. First thing that we will do is we will write down the definition of buffer solution. It is the solution which resists change in pH is called buffer solution, right? So first answer is over. Second, they are asking for the types. So what is the types? Types of the buffer solution is acidic buffer and basic buffer. we need to take the detail of this 2 buffer also, because it is costing the 5 marks, so we cannot just write the name and let it go. Okay, so we will describe the types of buffer solution in detail with some definitions also. So what is the third thing that comes is, see here, applications of the buffer solution is, it plays important role in textile industry, dyeing industry, paper production and sugar industry. They play important role in preparation of synthetic food. They play important role in chemical reactions like estimating water hardness. Okay, so very important thing is buffer solution importance. Why it is important? What are the applications of buffer in the routine life? Just like the importance of the pH, again it becomes a long answer of applications of the buffer solution. So in the textile field, if you are suppose not maintaining the proper pH of the solution, then the needed color shades will not be obtained. At the same time, you need to prepare the medicines with the proper buffering, otherwise the proper composition of the medicine will not be ensured. So there are many fields in which it plays very important role. Buffer solution application in textile field, also in the dyeing, paper production. Whenever you are doing any paper industry, pH and buffer plays very important role. Sugar industry, quality of sugar will depend on type of buffer used. Okay, used in preparation of synthetic foods. Then buffer solution is also used to estimate water hardness, that is in the experiments. So the answer that we have taken is, what was the question? What is buffer solution? We have described the definition. What are its types? Acidic and basic buffer. We have taken it. We will take it in the detail too. Here, types. Acidic buffer. How it is formed? Let us see. We have to write down the definition because it is of 5 marks. It is formed by mixing a solution of weak acid with an equally concentrated solution of salt formed by that acid with strong base. Okay, so it is formed by something buffer, mixing the weak acid solution with equally concentrated solution of that salt with weak acid and strong base. Just opposite of this is basic buffer, formed by mixing of solution of weak base with an equally concentrated solution of salt formed by that base with strong acid. So these are the types of the buffers. We have seen definition, we have seen types, we have seen applications. So now our all the answer is covered, and that is we are ensuring the 5 marks in the paper. Let us move ahead with the next question. What is half cell? Explain the construction and working of the standard hydrogen electrode.